So this is the lab for ANSYS simulation, right? So we model this the wind tunnel in SolidWorks. We apply the triangle measurement on the whole thing. Yeah, we apply triangle measurement on the whole thing, apply subdivision along the flat plane of like 300 subdivisions to make sure we have a lot of measures here to get accurate data, right? So, and so we did that, and we come here to your setup, right? Go to expressions, not that, I'm sorry, right? Your models, make sure energy is on, boundary conditions, inlet, with your inlet velocity to be your velocity magnitude of the hertz, and so it's 5.76. Right, right, calculate. So we drag coefficient, right? Do a, we go to report definitions, right? We create, in this case, I already made it, but so we go to new, um, blah, 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 blah. Yeah, you go to force report, you go drag, right? You can pop this up, right? And so make sure you make it to drag coefficient on drag force. Make sure it's over the surface of the flat plate that you named, right? So yes, whatever, click compute, do your thing, and close that, right? Make sure you have your contours for velocity setup. So you double click it, you name it velocity, velocity magnitude, make sure it's over the flat plate inlet and the interior surface so you can see all the and the velocities and the contours of velocity, right? Once you do that, make sure your initialization is the 5.76 of the velocity given your initial point. On calculate and do your calculations, and you will see the drag coefficient. And it's just a flat plate, you won't experience much drag at all, right? And to see the velocity advantage, come here, velocity, save and display, and you see the velocity contour. Right, so we go to plots, XY plots. Okay, you want to apply your skin friction and coefficient to do that. Have a double click XY plot, make a new plot, skin friction coefficient. Right, when the boxes will be, in white boxes, right, skin friction will be pick skin friction section, and you want your x-axis to be the direction vector. And make sure to over the flat plate to, it's what we're looking at the description are off, right? You say plot, right? And here we show, your skin friction of the flat plate. The same thing for washer stress, right? Open it up, look at plot name, washer stress, walk fluxes, washer stress, direction vector, flat plate, and say plot, and display all your data. And also forgot to mention for um, materials, right? Fluids, air. And make sure that it is these values, right? 1.2225. So with that, and yeah, your data, you need your washer and your drag coefficient and your skin friction. And as you finish that, you can just close this out. Right. So and then you go into results. Here you can see the velocity contour, right? You have that show up. um, They show up perfectly. You wanna have your line set up to find the laminar band layer velocity profile at that specific point. Right, to do that, you go in locations, line, right, you name it. So you gotta name it. I already did it. So, right, so here, right, you choose a point to what in this case would be right like here, right? So right, you name it. This is for like the very start, right? So you put the point to where the same distance was on the actual real life wind tunnel, right? So that's the 0.02 centimeters. Right, make the line thick, right? To make sure you can see where it is. You do the same thing for your 16 centimeter, and 8 centimeter here, right? Make sure your samples are 500, 500, 500. Make sure it runs a lot of calculations with accurate data. Okay, so whatever. So when you do that, you click apply. Make sure that, there you go. And you click apply. Right. And in order to see your graphs of the, and so you click here, right? A new graph, name what you need to name it, right? And pop up down here. So since I already done it, right? I got my velocity profiles. So usually you go, general, make it XY, there's series, right? So it'd be like series one, right? So you'll name it 0.02 centimeters and make sure you're picking out the location try to represent there, right? And then you click like add new, to name it like, so it again, right? So like 8 centimeters, oops, 8 centimeters, location, the 8 centimeter location, right? So once you do that for also the 16, your x-axis, you want to leave it as velocity u, and your y-axis should be y, should be your distance from the plate, across the boundary layer, right? So I set mine to be from between 0 and 0.6, like the head and right? Line display, make sure it's displaying all lines, right? And it'll pop up right here, right? You can see how the velocity changes along the y-axis. So since it's just a flat plate and boundary layer will be very far from this, it is expected to the graph to look for the velocities to be very similar, just slightly higher, right? Velocity just slightly increases as it goes, right? So if you want to check out your contour, right? This velocity contour. Basically just click over here, right? Show your contour, right? Sure, in this case I already did, and pop up right here in contour one. So as what the symmetry you're looking at, which in this case is symmetry true, right? Yeah, number of contours, label, and then you just click apply, and this will pop up, which is great. So we can, if you run it back step by step, right? So you suppose this, right? We'll go to the mesh. Right? So this is the mesh here, right? So see how the triangle's massive, I'll apply to the surface, right? The edge size and apply to the right object to trace all meshes on that side. And the edge sizing, so to concentrate more meshes around that object also. Right? So you have your name selection, your inlet, your walls, your outlet, and of course you want name selection by flat plate, which is what allowed me to, pick those points as the reference points to show me the data. Right? So when you do that, so we do it right, just right click, update mesh, right? You see how the mesh is here. Once it's on, let's close out. Right, go to setup, start. Wait for it to load. So, therefore, grab about the meshes that we made in front mesh. Then, once again, just keep your energies on. Materials with loading, for instance, it's there, right? It's, it's in a wind tunnel. Boundary inlet, make sure it's 5.76. Um, um, oh yeah, real quick, I forgot to mention reference values, right? Make sure this velocity is matching the velocity of the wind tunnel here. It's same as your dynamic, so it's 505. Right? So the reports, right? Turn coefficient, yada yada yada. Uh, let's do it one more time. So new, first report, drag, and then drag 5. In this case, we need 2, right? Over the 5 plate, K, K, initialization, click standard, make sure the velocity is the same, initialize, and initialize, right? So it means from calculation, calculate, and so let it go. So it's going to show you also our drag coefficient here, right? That we set up over here. So it's the expected results for it. So graphics controls, you're going to add velocity contour, here, and velocity magnitude. Make sure it's over the flat plate, walls, and the interior. And so it's display when you get velocity profile. Right. So for plots, you apply your and your XY friction, right? Come here, go to the washes and your wall fluxes, washer stress, right? Over the flat plate, say plot to show you, right? Do the same thing for the other one, for the skin frictions, right? Wall fluxes, skin friction coefficient for the flat plate, say plot to display it. So yeah, so we're doing that. Once again, set out, then you go to your results. Oh, oh, yes. Okay. So it's one calculation, you calculate, drag forward. I'm taking a long way because this is the instance where I added a lot more from a triangle. So So, so, those time, set up the lines where we need to be to find the plus part of those exact points. And then for here, click the chart, put the parameters and velocity chart, put the data to series and for things, your x plus the degree, your y is using the distance from the plate, explain chart and apply, you see your velocity focus here. Right. So that's everything. So thank you for watching and have a good day.